In this video, we want to learn some of the important terminology dealing with the graphs of polynomials, and then I'll show you how to find some information about polynomials using a graphing calculator. Because a lot of these are not really easy to graph by hand. The ones that we have down here, in theory, you could, but other ones not so much. So it is often easier to use a graphing calculator. So the first thing to know, or the first term to be familiar with, is something called the relative extrema. And extrema is like the plural version of the word extreme. The extreme points on a graph, you could either have maximum or minimums. So I'll show you what that looks like. Let's suppose we had a graph right here, and put this in red so it stands out a little bit better. Okay, and here's what the graph looks like. It looks just like that. Okay, this graph has what are called two extreme points, one maximum and one minimum. So this green point right here, that's called a relative maximum. The reason it's called a relative maximum is because relative to the other things around it, so like all of these blue points on its left and on its right side, it's higher than all of those things around it. Relatively speaking, it's the maximum point in that general neighborhood. But it's not the highest point on this graph. You look at this arrow right here, that's pointing up forever. So that graph is definitely going to be higher than the green point. That's why it's called a relative maximum instead of another term would be an absolute maximum. Okay, so it's not an absolute max, it is a relative max. If you had to guess, think about what that purple point would be called right there, and maybe you guess that that would be called a relative minimum. I'll just abbreviate that, relative min. Again, why is it relative min instead of absolute minimum? Because it's higher than all of these little points around it. But if you look over here, that graph does go down forever, so it's not the absolute minimum point. So that's the first thing to note, is what does that term mean, and that's exactly what it means. Second thing is the possible number of turning points that a graph could have. It's always one less than the degree of the graph, and I'll tell you what that means. Okay, then the highest degree, I should say. So the highest degree on a polynomial is simply whatever exponent it has as its highest exponent. So I'll give you two examples right here. Call this a and b. So let's say our first function is this right here, plus 7x squared minus 10. And let's say our second function is, let's say, I'll kind of mix this up a little bit, 8x to the 40th minus 7x to the 20th plus 10x to the 100th minus 5. So kind of a crazy equation there. So here's what we mean by turning points. Basically, it means that if you were to graph this function right here, it could have, at most, it could have one less than that number of turning points. So it could have at most 4 turning points. And what does a turning point even mean? Turning point basically means these, on this graph right here, those two blue points that I just made, those are both turning points. It's where the graph turns from going up, which it's going up right here, and then suddenly here it starts going down. Okay, and basically turning points are another way of saying maximums or minimums. That's when the graph turns. So x to the 5th could have at most 5 turning points. If you look at this second equation, what's the highest degree? And the highest degree is 100. So this could have at most 99 turning points. Okay, when I say at most, what that means is it doesn't actually have to have that many. That's the maximum number it could have, but it could have anything less than that as well. And then finally, this is very important. The fundamental theorem of algebra, you can kind of tell from the name, it must be pretty important. This answers the question, how many zeros does a polynomial have? By zeros, we mean how many times does it hit the x-axis. So I'll highlight those up here. These, I guess that's not a good color. Let me pick another color that stands out a little bit better. Let's try orange here. It's probably still not good, but hopefully you can see it. All right. So those 3 orange points that I just put on the graph, those are all zeros, and they're called zeros because that's where y equals 0. How many zeros does a polynomial have? It always has the number, or I should say it has the number of zeros that a polynomial has is equal to its highest degree. And what I mean by that is, let's say we had this function y equals x to the 10th minus 5x to the 3rd plus 4x squared. I'm just making up a random polynomial here. Okay, the highest degree right here is this. It has a degree of 10. So that means that polynomial will have 10 ways that you can make it 0. It will have 10 zeros. Okay, not all of these have to be real numbers. So we'll talk about, we have talked about imaginary numbers. Okay, not all of these will be real numbers. They will at least be, they could be imaginary, but the point is in total we'll have a total of 10 zeros. Any zeros that are real will show up on the graph, like those orange ones right here, but any that are imaginary will not. Okay, so those are the three important things to know before we start to graph. The relative maximum minimum just means the highest or lowest points in that general neighborhood. Number of turning points is always one less than the highest degree. So like this 1x to the 10th could have at most, at maximum, it could have 9 turning points. It doesn't have to have that many. And then finally, the fundamental theorem of algebra means that whatever the highest degree is, that's how many zeros or solutions that polynomial will have. Zeros is another name for solutions, or x-intercepts, meaning where it hits the x-axis. So with those things in mind, let's try both of these. We'll do the first together, and I encourage you to pause and at any point where you feel like you could proceed and try to do the rest by yourself. But here's what it asks us to do. It says for each graph state the number of possible zeros, and then we have to find them. And then secondly, find the relative extreme points of the max and the min and the number of possible turning points. So before we graph, let's answer some of these. So the number of turning points could be at most 3 because that's x to the 4th. So I should say max turning points could be at most 3. The number of zeros here could be, or not could be, it has to be 4. They may not all be real zeros, but it has to have 4 because that's x to the 4th. Okay, and then the extreme points we don't know. And then the end behavior, we've talked about this as well, or should talk about this. The end behavior just means where does the graph end up. So for example, x to the 4th is going to look something like a parabola. That means this right here, the function is going up to infinity, but it's going to infinity in the positive direction. And then over here, it's doing the same thing. It's going, and that's what those arrows mean right here. Arrow means f of x, the function, is traveling. Arrow means traveling to infinity, and the plus infinity, that's the symbol for infinity. Plus infinity means in the positive direction. So we want to use a graphing calculator for this. So I've punched that function into y equals right there. Hopefully you can see it. And then I'm going to go to graph, and if the picture doesn't work, you can go to zoom standard or zoom in and out as needed. I've kind of already done that. Here's what the graph looks like. We said it could have at most 3 turning points, and you can see it does. Right here where my cursor is, there's another turning point, that's a maximum, and then right there it has a minimum. And it's x to the 4th, it's an even numbered power, so it looks like a parabola, which all even numbered polynomials will. So let's find the zeros. So we'll go to second calc 0, and there are 4 zeros, so we have to carefully tell it which ones we want. So I'm going to go to the left of that first 0, press enter. To the right, press enter again, and press enter a third time. There's 1 0. At x equals -1, there's a 0. And again, we could always test that by plugging in -1. So I'll go back to second calc, find the next 0. Okay, now I'm to the left of this other 0 right here, enter. Go a little bit to the right, enter, and then enter again. And we have another 0 at x equals 0. Okay, then let's go to second calc. Remember, we're supposed to have 4 zeros, and you can see probably all 4. So I'm going to the left of this other 0. Press enter twice more, so 3 times in total. So x equals -1, x equals 0, x equals +1. Those are our zeros so far. Let's get the last one. We'll go to the left right here, enter, enter again, and our last 0 is at x equals 2. So there's our 4 zeros. Let's find the extreme points. We have 2 maxes and 2 mins. So let's go for the min first. Since we're over here, we'll go to the left of that one, enter. We'll go to the right, enter, enter one more time. And our first minimum is at x equals 1.62, it looks like. Let's get our second minimum on the other side of the graph. And by the way, the y value right there was, the previous one was -1. Right here it looks like same thing. X equals -0.62, y equals -1 would be our other min. And then remember, it has 3 turning points, which makes sense. Now I just hit 4 for maximum there. Go to the left of that max, to the right of that max, enter 3 times in total, and our max is at x equals 0.5, about 1/2, y equals 0.562. So see if you can pause and try to do this second function right there, the negative x cubed. By the way, the negative is going to mean that it's kind of like when you put a negative in front of a parabola, it reverses it. Alright, so let's plug that in. So let's make sure I have it. Negative x cubed plus 3x squared minus 2x. It should have, before we even graph this, let's get our values that we'd be able to figure out. This should have a total of 3 zeros, and we know that because that's x to the 3. It could have a max number of turns of 2 because it's always 1 less than that. And then from there we'll graph the rest and see what it looks like. So I'm going to y equals, we'll clear this. Remember to use the negative that just lit up in red right there. Don't use the minus sign. X, and then this little caret symbol, that arrow that I just hit that lit up, and then I'll go to 3. Here's the other thing, you have to make sure that you press arrow again. You can see right here it's kind of smaller, and then I pressed arrow so the blinking black cursor comes down. That's important because otherwise you would be typing the rest of your stuff up in that exponent, and you don't want to do that. So it's plus 3x squared and then minus 2x. So let's fill that in, minus 2x. We will hit graph right here, and hopefully we'll get a decent picture. Takes a little while to load. That looks good. Looks like it does have 2 turning points. Let's zoom in a little so we can see that better. So I hit zoom in, and then you have to move this to where you want it to zoom in. All the important stuff is happening in that region, so I just zoomed in right there so we can get a better picture. And you can see now, we can see clearly there's a max and a min, there's 2 turning points, and there's 3 zeros. So let's find those right now. So second calc, we will go to 0, and we'll go again to the left of this 0, enter, to the right, enter, enter one more time. So our first 0 is at 0, 0, and you can kind of tell looking at that equation, if you plugged in x equals 0, you would definitely get y equals 0 as well. Then let's go over here, enter on the left, then we have enter on the right, enter one more time. X equals 1, that's another 0, and you might be able to tell that these polynomials will also, you could factor them. So maybe we'll do that in just a sec just to test it. So 0, 1, and then the last one is at 2. Okay, and then the max and the min. So let's get the max first, since we're in that region of the graph. So here's the max. I'm going to go a little to the left and a little to the right. In terms of how you could know when to find max and mins, or how many that it's going to have, that is the max right there, 1.58, 0.38. You really need to know calculus for that. You'll study that a lot more in calculus. But for now, in terms of how many maxes and mins, for now, this is what we're doing here to find those. So now we're going to find the min, and we press enter twice, and there's our min. I just want to show you that those 3 zeros we got, we could have actually done this by factoring. So here's how we would have done that. Let's take this and factor out a negative x, negative because of that. So we'll pull out a negative x. This thing divided by negative x would be x squared. This divided by negative x would be negative 3x. This divided by negative x would be positive 2. And then you could probably see we can factor this even further. What multiplies to 2 and adds to negative 3? X minus 2, x minus 1. So you can see x equals 0 would be that 0. That one would be x equals 2. That one would be x equals 1. So that's just to show you that we get the same answer doing it both ways.